Hi all, in this video we are going to see about STP Spanning Tree Protocol. What is STP and how does STP works? First of all, what is an STP? STP is a Spanning Tree Protocol. It helps to avoid loops in the switched network. If we create a redundancy for a network that is considered here, if there is a switch for a redundancy, we are just keeping it two cables over here, two cable connectivity. If suppose one cable gets connected due to some issues, the data should be transmitted via the next cable. That's why we keep a redundancy in the network. But keeping redundancy, there is another issue, which is called as creates loops in the network. The switch should forward a frame from this interface. It goes to over here, and again the same way, the same frame will be gets to this interface, and it will come to the switch and again to the back to the first switch. So what does it occurs? It just creates the loops in the network from one switch to other switch, from the other switch to the again to the same switch. So it occurs in the it creates some sort of loop and occurs and results in some sort of issues. So the data transmission might not be possible in such a network. So STP plays a vital role over here, which helps to avoid loops in the network. How do we get a loop over here? Let's consider the same scenario over here. Suppose if this PC1 wants to reach the PC2, what does it do? It just sends, I need to reach this, consider reach, tell me how to reach or send the data over there. That's what it sends to the switch. So what does the switch? It sends whatever the frames that is being received, it will just forward to the other end. In all the ports except the port that is being received. Since it is now doing a broadcast frame, it will just gives it to all other ports. If it has been receiving faster than 0/3, it will be given to these two ports, faster than 0/1 and 0/2. It will be received here, this interface, and this interface will receive the frame. And automatically, what does it do? The faster than 0/2 frame, what it receives on faster than 0/2 frame on this switch, it will be sending it back to the faster than 0/1 frame. It will be received on this switch. Whatever the information that is received on faster than 0/1, it will be sent on to this interface. So automatically this will also go to the switch. So again, whatever the interface information that is getting into this, it will go here. This information will be getting into this. This will create a loop in the network. It will loop forever. Since the Ethernet frame doesn't have any time to loop packet, it will just looping it into the switch itself. In order to overcome this loop, we are creating a protocol that is nothing but a spanning tree protocol, which helps to avoid loops in the network. How does the spanning tree protocol works in the sense? First of all, if there is a redundancy in the network, the switch has to choose root bridge. The root bridge is selected based on the bridge ID. The bridge ID is nothing but a combination of priority and a MAC address. What is a root bridge in the sense? It acts like a master which helps to resolve the spanning tree based on the root bridge only. BPDU is nothing but a special frame that helps for a spanning tree to work. That's it, BPDU. How does the STP works? First of all, spanning tree, as I said earlier, first of all, the spanning tree will elect a root bridge. The root bridge is selected based on the bridge ID. What is the bridge ID? Is nothing but a combination of priority and MAC address. First, initially, it will check for priority. If priority is the same, then it will look into the MAC address. Priority, as lower the priority is being choose better, and the same way the lower the MAC address will be choose better. First, if it looks into the priority, if the priority wins, if it can elect with the help of priority itself, it won't look into the MAC address. Automatically, priority will be done. If a priority is same, then only it will look into the MAC address. By using a MAC address, it lower the MAC address, it will elect which switch will become the root bridge, and that's it. The process goes on, and the root bridge elected, and the process just gets how the STP works, the further proceedings. Next, the root bridge. As I said earlier, the root bridge is based on the bridge ID. Priority and MAC is a combination of bridge ID. Lower the bridge ID will be elected as a root bridge. And one more thing you have to make a note of it. All the ports in the root bridge will become forwarding port. That is in the designated port and will be in the forwarding state. All the ports in the root bridge. What are the ports that STP has? STP has 3 sets of ports. That is nothing but a designated port, root port, and alternate port. What is that port? Designated port, as I said earlier, all ports in the root bridge will be the designated port and will be in the forwarding state. What is a root port? Root port is nothing but the shortest path to reach the root bridge. The interface that is having a shortest path to reach the root bridge is said to be as a root port. Only one root port is valid in the switch. If a switch is having 3 or 4 ports, the 4 interfaces that is being connected to the switch, only one interface will be elected as a root port. Other interface might be in designated or a alternate port. The shortest path is based on the interface cost. It is not based on the how much switches we are causing. It's not based on that. It's based on the interface cost. What is the interface cost? We just look into the next slide. What is an alternate port? Alternate port is nothing but it will be some sort of in the blocking mode, and once the designated or once the root port, whatever the other ports gets down, automatically the alternate port will changes its role to become the concerned port. What is the cost? The default cost value has been given here for 1 gig, 100 M and 10 M. This is a default cost value, but if you want, we can just change it. Lower the cost is the better to reach the root bridge. What is this cost? Based on this cost value, lower the cost is being elected. The interface, lower the cost value with the interface will be elected to reach the root bridge. In the sense, consider a 4 gig interface. Single gig interface with a 4 interfaces with a gig interface. That is a 4 purpose of 16. It is equal to 16 cost value which is having, and fast Ethernet which is 100 M interface which is having a 19 cost value. The switch will choose a 4 gig interface, 1 gig interface to reach a root bridge than a 100 M interface. The reason is it takes a cost of only 16, while the fast Ethernet interface which is directly connected can use a cost of 19. So in the sense that it will choose a lower the cost. Lower the cost is 16, so automatically choose a gigabit interface as compared to that of a fast Ethernet interface. This is how the cost works. And then the basic, what is a STP command? The basic STP command that most of the people use is the show spanning tree. What is the show spanning tree? What are the information that it will give is who is a root bridge and what is our status and how to reach a root bridge. What is the cost to reach a root bridge? By which interface we are going to reach the interface root bridge, and what are our port states and what are our MAC address and root bridge MAC address. This information will all comes under show spanning tree command. What are the ports? If you look into the ports, in the sense you will be seeing 4 port states. There is nothing but a blocking, listening, learning, and forwarding. Blocking state, it will occurs in 20 seconds. What is the blocking stage? Blocking stage is nothing but similar to the alternate port. It is nothing but an alternate port. It will not occur frequently. Once it is in blocking mode, it will if it is changing to another state, that is from blocking to designated port, if it is been changing, means at that sense only the blocking state will occur, or else it will not be getting to over. Next we look into the listening, learning, and forwarding. What is the listening stage? Listening stage, when once we get a connectivity, we are initiating a connectivity out that interface, the listening stage will be there. It will take for around 15 seconds. Next, after 15 seconds, it will just move on to the learning stage. After 15 seconds, it will be moving on to the forwarding stage. So from listening, it will take 30 seconds in order to reach the forwarding stage. So what are the information that we can get in the listening stage? Listening stage can only send BPDUs. That is, who is whether the other port can become a root bridge or we can become a root bridge. The information who is going to be the which port is going to the root port, that information and all is maintained in the listening stage. That is, BPDUs are transmitted. That's what listening stage can do. Then in the learning stage, BPDUs can transmit, and at the same time the MAC address can be learned, and data transmission will not be possible. Only the MAC address it can learn in learning stage. Well, in case of forwarding stage, we can send the BPDUs, we can learn MAC address, and at the same time we can send a data transmission in the forwarding stage. That's what a forwarding stage can do. Next, a port fast. What is a port fast and where it is being used? Suppose if your switch is being connected to a PC or a host, and considered to be as a server or a PC or host, what will be, there is no need to send a BPDUs, because however the host doesn't send any BPDUs back to you. Only the switches will send a BPDUs in order to confirm whether the other switch having a better bridge ID. In order to get the information, we are just sending a BPDUs. While in case of the host, however, it will not send the BPDUs back to you. So sending of BPDUs to the host is unnecessary. In order to avoid the BPDU sending to a host, we are just enabling a port fast in the interface. While if you are enabling a port fast, what is the change occurs in the spanning tree is that it will just moving on from direct, it will just skipping off a listening and learning mode, and it will directly moving on to the forwarding state. So it helps to avoid 30 seconds, so it can perform a little faster as compared to that of a BPDU's interface. And make a note of it, it should be enabled only on the access port, not on the trunk port. That's it about a port fast. And one more thing, here a clear explanation about how STP works in the sense, just consider to be as a switch A, switch B and switch C, all having a same priority, and consider as it has a MAC address of 111, 222 and 333. Consider to be it has a MAC address of 111, 222 and 333. Initially, see here what this is a loop network. Since switch A is connected to switch B is connected to switch C, and switch C is again connected to switch A. So if a data is coming over here, it will come over here and again come over here. So this is some sort of loop in the network. So how does we can avoid over here is that, first consider a switch A. It will elect a root bridge. How does it elect a root bridge? First, initially it will check for the bridge ID. What is the bridge ID? It's a combination of priority and a MAC address. Priority is same. As I said earlier, priority will be the same in the sense it will just look into the MAC address. Here's the MAC address is 111, 222 and 333. What does it then do? The lower the MAC address will be preferable. So automatically this switch will become the bridge ID. Sorry, root bridge. Based on this will become the root bridge. This will become the root bridge. So next step, once it becomes a root bridge, all the ports in the root bridge will become the designated port. The next step is to elect a root port. So what is a root port? The shortest path to reach the root bridge is said to be as a root port. So in this case, consider all the interfaces are having a same cost. All the interfaces having a same cost in the sense, then it needs to same cost. It can directly which is the interface that can become, you can directly easily select it. So in this sense, it will become this port, and switch C will has this port as a root port. So what about these two ports? What about the states of these two ports? If we want to know about this, is we just want to check into the again a root bridge. What is priority will be the same, and MAC address is a tiebreaker, and then this 2 has a MAC address of 222 and 333. Obviously, the switch B wins the battle, so automatically switch B. This port will become the designated port, and the loser will get alternate or a blocked port. Alternate or blocked port will be in blocked mode. It will be in the alternate or blocked port. So what happens is that it will not send any information to the concerned switch. The information will be going from this port to this port. So whatever the information that you are giving is via the root port and designated port only go. It will not go via alternate or backup port. Suppose if any of the interfaces, this interface or this interface gets down, at this case, automatically the alternate port will just gets back to the role of designated or root port based on the needs. So this is how the spanning tree works, and that's it about spanning tree. Thanks for watching. Until next time.